Hello everyone. In this video, I am going to share with you about the MCQs which are based on the topic homogeneous function and Euler's theorem. This topic is very important from the MCQ point of view, and this is part of a partial derivatives. So let's see, before talking about the MCQs, I want to discuss quickly the important results which are useful for that. So point 1 is first remember that how do we define any function as a homogeneous function. So these are the three techniques. Either we can replace the variable by some parameter t or lambda, and if that parameter will have some power and you get back the function, it means it is a homogeneous function. Or other way is the variable can also be taken common and it can be written as x to the power n something y by x or y to the power n something. So that n will tell you the degree. So degree is important about the homogeneous function. Even the same logic can be applicable to 3 or n number of variables. So let's see one important theorem which is called Euler's theorem, and this theorem is applicable only over the homogeneous functions. And you will find out this expression that whenever there is a function, let's say u is a function and its degree is n, and we'll see this expression that x is multiplied with the partial derivative of u with x and y is multiplied with partial derivative with respect to y, and there is a addition. It is always equals to degree times the function. And same thing can be applicable if it is a 3 variable, or it can be applicable if there are n variable. So that is a one point. Another important result is if we want to see the double derivatives, so this first second are also a result, but the most frequently one we use here, the third one, wherein we take the double derivatives where double derivative x mix 1 and y square are there and the same types of variable are multiplied. In that case, this expression is always equals to degree and one less value of the degree times u. So n into n minus 1 times u. So that becomes again a important expression. Then there is a one deduced result, or you can say the modified form of Euler's theorem, wherein this result is again, see, you are interested in u because their expression is again given in u, but u is not homogeneous, and we see that there is some function allied with one expression, and that expression here I am writing Tn. This expression is homogeneous and it's a degree n. So what we can do, we can change this expression into the new one by transferring the function on u side, and let's say this new function become f of u, because in the formula I am going to use this f of u, because Tn and f of u are equal. Tn is homogeneous, so this will be also homogeneous. Its degree is n, so its degree will also be n. In that case, your expression will not equals to now n into u, it will be n times numerator function, denominator derivative of the function. Now there might be few questions over the same kind of expression, but here it is a double derivatives. In double derivative we can extend this answer. What we can do, whatever answer we are getting here with the first derivatives, let's say this whole expression I am writing here as some new function, let's say g of u. If this expression is in the first derivative and somebody is asking you the double derivative over the same kind of situation, so we can do it very quickly. Instead of doing it in detail, what we can do, we write this first derivative expression which we are calling here gu, and in the bracket derivative minus 1. So this is one of the important result. Some last question I have talked about this last discussion. And one more point before we switch over to the MCQs. Sometimes we again see that there is a z given in the question, and we are observing that the same kind of expressions in one derivative and two derivatives are there, but z might not be homogeneous of the single degree. There might be the mixture, like there might be one function u, one function v of a different degrees, and they both are homogeneous. Let's say u is a homogeneous of degree m and v is a homogeneous of degree n, which is not different. Let's say if they are different, now what we can do, we can apply the same Euler's theorem, and after simplifying, the result will come up as that if u is a homogeneous degree of m, so it will be m times u and v n times v. So this can be the right side. And this expression, if you want to extend to the double derivative, here m into m minus 1 times this plus n into n minus 1, because derivative is linear. So if the linearity property is satisfied over here, the same can be extended. So we will see in the last few questions based on these property. So let's jump into this problem solving. The first question is, which of the following is not homogeneous? Now there are various ways. Either you can apply definition or you can use the shortcut. So I would like to share with you the shortcuts. When you see these functions, we are observing that this function is already in the standard form. Like here you can write down this as a y0. So this is already in the standard form by definition form. So you can say it is a homogeneous of degree 0. This is also homogeneous of degree 0. This is also homogeneous of degree that is degree 1. Sorry, here it is 1. And this one is a not homogeneous function. Reason being, you can observe, I have explained here that when we simplify, we are not able to get the function back. So the one very important clue is, whenever you see some function, inside there is an expression and the degree is not 0. If degree is not 0 inside expression, it will never comes as a homogeneous. So this part is the D option. Here we want to find out which of the following function is a homogeneous of degree minus 2. Minus 2 we are looking for. So minus 2, we can easily see that this A option is the correct. A is a homogeneous of degree 2, B is for that is minus 2, this is for 2, and these two are not homogeneous. I made an explanation so that if any one of you have any query, so you can clarify it, because there the powers are different. When you are having a polynomial or the rational, the power of every term should be same. If it is a rational, numerator should be all same, denominator should all same. So if some of you want to understand this topic of homogeneous and Euler's theorem and how to find degree, I have made some videos on my channel, so you can go through it. That is a detailed procedure discussed, or I'll mention link below. Come to the question number 3. Here we want to find out which of the following is of degree minus 3. Here we can see all are these are rational function. Here degree numerator 1, denominator is 4. Now I want to share here, whenever you see under root sign and some terms are there. So if you want to find the quick degree of this denominator, so inside 8 whole half. So you have to do half of 8 is 4, and here numerator are all 1, it is 1. The final degree will be the difference, 1 minus 4 is minus 3. So A become the option, because B degree is numerator 1, denominator half, not so here it is 4 and denominator 1, which is 3, and here it is already in the standard form, degree 2. So out of these three, the appropriate option as per the required degree minus 3 is A. In this case, we again want to find out the degrees. I've discussed few questions in the starting for the degrees, and here you can see the numerator power is 2 with half, because under root means half. Half of 2 is 1 and denominator is also 1, so 1 minus 1 is 0. So the degree is 0, option A. Here the degree, it is already in the standard form. You can see that it is by definition. We can see the power of x here 2, and you can call a, whenever you see the definition means inside term should have a same degree whenever there is any function. So here it is 2. Here this is again, when you see this expression 6, this degree is also 2, because when you simplify and you will come up with that the common power is 2 over here in all the questions, because here inside even if you put the t formula like t square, t everywhere t x square, and here if you put, so inside t will get cancelled, outside t square can be common, so the power of t is 2, so 2 is the degree. Now I've started the Euler's theorem question. So we see here that whenever we see this expression, immediately the Euler's theorem can be utilized after looking into the function's behavior. If it is an homogeneous and if its degree is n, we can put it equals to n times the function. So right now the current question, here the numerator all are 2, denominator 1, so the difference is 1. So it is a homogeneous function of degree 1, so 1 times z is z, so B option. Eighth question, here this is extended to 3 variable but logic is same. Now you are observing that this is a homogeneous function and the homogeneous function is of degree 2, and this side is again the Euler's theorem expression. 3 variable will have a 3 expression. In that case what we got, that this is equals to 2 times u, so 2 times u, lambda value over here is 2, so option B is the right one. This again a standard function, and we want to first find out whether it is homogeneous or not. Yes, it is homogeneous because inside both terms are 2. When you are observing 2 and the common power is minus half, so 2 times minus half is minus 1. So this is whole expression is of degree minus 1, which is homogeneous function. So minus times the function. So here the name of the function is f, so you will get a minus of f. So B is the right option. So it is a homogeneous function. This 10th question is also homogeneous function and degree is minus 3. So you can see all term, when you put t cube here, t cube come from here, everywhere t cube come, and there is no term in the denominator, so you are getting t to the power minus 2 times the function t minus cube, and minus 3 times the function will be the answer for this expression, because this expression we all are using the Euler's theorem, direct result of the Euler's. Here also Euler's theorem will be calculated and the function is homogeneous. Why? Because when you simplify, it can be written as, you can keep x0 common to fit into the definition, and we get that it is of degree 0 and 0 into this z. So this z is already a homogeneous function but degree is 0. So 0 times the function is 0. So C is the right option for 11th question. And here this is a second order expression. In second, first of all, let us ensure that whether this function is homogeneous or not. So it is a homogeneous function of degree 2 because it is already in the standard form, or you can say the definition form. And when we see the degree and we got that u is a homogeneous function, and formula for the double derivative of Euler's theorem is n into n minus 1 times the function. So n is 2 and 1 less than 2 is 1, so 2 into 1 into u become a 2u, so D become the right option. Here this function is again direct, and we are observing that here x into y, f of xy. So f of xy, when it is written, it will get cancelled t, and here t will be only having a 1 1. So x and y both when clubbed together will make a degree 2, and n is 2 over here. And when we apply the Euler's theorem, and we are going to get that equals to 2z. So that become D become the right option. Now comes the modified version. If you see this question, here we are observing that again u is the question and means function, and we are having the same kind of Euler's theorem expression. But right now if we observe, this is not a homogeneous function. U is not a homogeneous function because when you put, you are not able to get any of it into any of the definition. And but we are observing without tan inverse, if you see this expression, then it is an homogeneous function, and this expression degree is 2. So what we can do, we can do some modification by transferring the function on the other side. So what we observe, that u was not homogeneous but its function is homogeneous, means tan of u is homogeneous, because here expression is in u but function not u, tan u is coming up. So the formula for that is, which we have discussed in the beginning, that it is n times function upon its derivative. So this is a shortcut formula, we do not need to calculate it. After simplification we left with this term. So we in MCQs better to use this formula. So here tan u will come in the numerator denominator become its derivative, and we have seen that this answer is not visible anywhere, so it means we can, it's a trigonometric function, so we can simplify it by applying the formulas. We can apply this, we can rewrite secant square as a cos square, and tan can be written as sine by cos, and after simplification we get 2 sin u cos u, and 2 sin u cos u is nothing but sine 2u, so that's why C is the right answer. So here now we are observing some questions of the modified. You can see this 15th question is also something wherein we can see, but this is not, this term is having something extra. So let us first focus over that what is the value of x del u by del x plus y del u by del y. We put it over here and then simplify. Now here u is cos inverse, and I know that inside expression is having a mismatch degree. Whenever we have any function and inside there is a rational and it is of different powers, so it is not a homogeneous function. But if we see this rational function separately, this is a homogeneous function, and we can see numerator power is 1, denominator is half, the difference of 1 and minus 1 half is half. So we got a half. This is a homogeneous function. So if you shift cos inverse on the other side, it become cos of u. So cos of u will also have the same degree whatever you have seen inside. So you can take help of this interior function, and the same degree can be fit into the whatever function is allied to u. So here what we can do, we can apply n, we can put the function here, we can put the derivative here, and we are getting minus half times cot of u, and minus half times cot of u is the value of this expression, but the current question is having something extra. So when minus half of cot u, there is a plus cot u, when it get cancelled it will be 0. So be careful, don't quickly jump into this D option. Reason being, this is not asking only the expression, something is added over here. So A become the right option. This is again a function which is not homogeneous, reason being log of something is there, we cannot separate power of t from here. So what we will do, we are going to use here the degree of homogeneous function, the interior portion is homogeneous. So what we can do, we can shift the log on the other side. When you shift the log on the other side, that becomes e of u. So e of u is a homogeneous function, same degree, the interior portion degree is 3, so it is a homogeneous function of degree 3. And what we can do, we apply the same logic, function on the top, derivative on the bottom, and we are getting 3 times eu divided by derivative of u. So eu, whenever you have an exponent, it always get cancelled, we left with the degree. So here it is 3, so not 3 of u, because eu will get cancelled. 17th question is almost the same, you can do it in the same manner. It is sign when shifted on this side, because this function is not homogeneous but the interior part is. So you are observing from the last few questions there is a pattern, and this pattern can be utilized. So whenever you see the original function is not homogeneous but the something inside is homogeneous, you can shift the function, apply the formula n times function upon its derivative. So here it is tan of u. Here comes the question which is I would say something which I shared in the last, the property, where you observe that when you see z, you can see this is again a expression of Euler's theorem, but we can see here that here the z is not giving me any single degree, so I can see it separately. I can see this function, I can see this as another function. I'll call this function as a u and this function as a v, and observe that this u is of degree 1 because x is there outside, and here nothing is there, so it is 0. So degree of u is 1 and degree of v is 0. So if you apply that formula m times u plus n times v, so m is 1 and n is 0, so we get only u, but here answer is nowhere u form, it is given in the question form. So you can say that u is actually this x into f of y by x. So this become the answer, D become the option. And if the same thing can be, I have taken the same question and created a double derivative. In a double derivative we have the same formula like m into m minus 1. So here you can use the formula, this is m, this is m minus 1, and this is n, this is n minus 1. So both become 0 because 1 minus 1 will also make it 0. So in this case a become option. I'm again repeating why I introduce this two new function. Reason being, we can here, let me make this, there is some error in the question. Here it is y square, here it is x square, and here also it is 2xy. Okay, so if x square del 2u by del x square plus 2xy del 2z by del xy, and there it is a y square times del 2z by del y square, and we are observing that in this case we are not having any this function is not having the same degree. This is different, this is different. So now onward when you see the expression is of the Euler's theorem, but the function is addition of two different homogeneous function of a different degree. So we can apply this formula. So here is the last question wherein I have used that deduction form. In the deduction form you can see, let me take you back to that slide so that we can talk about this formula. You can see here that if u is not homogeneous but some function of u is homogeneous, if the second order derivative expression is there, you if you know the answer, if it is not known, first calculate it. If it is already given, like in my MCQ it is already given, and I am calling this expression as a g of u, so the second derivative will become this function put here, take a derivative minus 1, you will get the answer. So I am going to apply the same strategy. What we can do, here the first order derivative is already given. If it is not given, I would have to calculate it. Reason being, the expression is in u but function is given of tan of u. So here also you can do the same activity. So this function I am calling gu. So as per the shortcut formula, write the function, inside bracket write its derivative minus 1. So when you see the derivative of this sine of 2u, it is 2 times cos 2u minus 1. But I am observing nowhere the answer is visible. It means inside I can see here this part is okay but inside is not okay. So what I can do? Apply the half angle formula, because when you see sine is there, other options are not correct. I want to see that whether I'll get this expression or not. So what I can do, I'll apply the half angle formula of cos 2 theta. This is 1 minus 2 sine square theta. So when you apply the formula and simplify, you'll get a 2 minus 4. So 2 minus 1 become 1 minus 4 sine square, and B become the right option. So I hope you have gotten some clarity. I have added all the topics of the important topics which covers the homogeneous function and the degrees, then Euler's theorem, then modified version. So I hope you will get some benefit from it. Thank you.